Hello everyone, welcome back to my channel. My name is Atul. In this session, we'll be covering chapter 4. In chapter 4, in earlier lessons, we have covered Minikube and Kubernetes installation in AWS. So right now, we'll be covering lesson 3, and lesson 3 is Kubernetes on VMware. So earlier, not everyone wanted to install the Kubernetes lab on AWS, and some folks want Kubernetes on VMware because it's a bit costly and it's not very costly, and we can install the lab in our laptop or maybe small servers and not too much expenses, and we can some directly install three machine, but our configuration should be good. So in my laptop consists of 16 GB of RAM, which in which like something like 8 to 9 GB OS is taking, and after that I'll be giving it to my VMware machines. And this is i5 CPU, so it's better like i5 or R7 CPU should be will be required. So I3 can be possible, but it will be very slow while doing it. Okay, so let's move forward. So let's move forward with the chapter 4, and this is lesson 3. So this is again hierarchical structure. So okay, let's learn about the prerequisite of it. So what is prerequisite? Prerequisite is RHEL 9 instances. We need it like three RHEL 9 instances. One is for master and two is for worker nodes like worker 01 and worker 2. So it's a minimum configuration. It's a 2 GB RAM is required and two CPUs are required and minimum 20 GB of free disk is required. Okay, so as usual, we'll be going through each and every step. So what all tasks we'll be performing in this lesson. And lesson one, then once this is done, then we'll be moving forward toward a practical lab. In the practical lab, I'll be showing you this step one by one. Apart from that, I'll be showing you lab how to execute the lab, and it is very useful and it's very easy. Let's move forward. Let's learn about what we'll be doing. So we'll be deploying the cluster with the help of kubeadm. So initially we have seen there are too many ways. So minikube we already learned, and this is second way like a kubeadm. So we'll be using kubeadm later how to do the changes. Okay. So in this we'll be using three RHEL instances. So three RHEL will be three nodes. So node 1, 2, 3, and we'll be using master nodes and worker nodes. So here will be one master node and a two worker node 01 and worker node 02. Okay, so suppose this is the IP. So once we install the server, then we'll be getting some IP. So we'll be updating the IPs here in our settings. Okay, and once we receive the server, then we'll be changing its host name. So host name should be in a such a fashion whenever we are running some commands or firing some command. So it should reflect that this is a master node. We are working on worker 01. We are working on worker 02. Okay, so once we get the server, we'll be updating a host file entry. Host file entry is required just to, so that making a communication will be easy for us. So we'll be making an entry such a way so in case if we wanted to communicate to from master to 01 or 02, then it's easily possible. Okay, then this is a major step like pinging all the boxes. So whenever we create a server, so all box should communicate to each other. In case if they won't be communicating, then again it's a problem. So then in case if we won't check it right now, then what will happen? We'll be stuck in some issues and we'll not be able to find out what is the issue. So in case if they all three machines are will be able to communicate each other, then in case some error comes in, that will be easy for us to identify what is the main cause of issue. Okay, so Kubernetes won't allow any swap partition. So swapping will be disabling, and SE Linux. SE Linux again kind of firewall. So we wanted to disable this firewall. Okay, and we'll be adding some kernel modules, and here like what we have written in all hosts. So we have to write some commands in all hosts and some commands in master node only. So here I have written in all hosts. So we have to swap partition host. So disable SE Linux, but in all host. Okay, then in master node only. So there are some kernel modules available, and so let's update some kernel modules here. So these kernel modules are temporary only. So, but in order to make it permanent, so in a master node, we'll be adding a file, and it is a k8s.conf file, and we'll be adding these settings. Okay, so there is some IP forwarding kernel parameters. So kernel parameters will be adding. So this is basically required as a Kubernetes prerequisite. So we don't have nothing to do. Some settings are required while we installing some software. So let's execute in this way. Okay, then whatever the parameters we have defined here with the help of sysctl command, we'll be loading all the parameters. Okay, and sometimes some firewall is added in the middle, so we have to open some ports with the help of firewall. So in case these ports are not open, then our servers won't work perfectly. So whenever we want, we need to open these ports, and this is with respect to master node. With respect to worker node, these ports should be opened. Okay, and okay, so here like a container D, or mean to say like some containerized environment we need to use whenever we run Kubernetes. So here we'll be using container D. So container D is the application or mean to some software which we'll be using, and because right now in Linux box RHEL 9, this Docker container won't come by default installation. So we'll be just downloading its repo. After downloading the repo, we'll be installing its container D. So once container is installed, then we'll be starting and enabling its services. So, and the next point is systemd group. So this is systemd group is a setting which is required by container. And what we want whenever a container D in start, it will be coming with this configuration. So what we are doing in this command, we'll be configuring a container D configuration. So there's a 2ml file, toml file. So okay, apart from that, then we'll be restarting container D setting. Now our turn comes for Kubernetes repo addition. So this way again, Kubernetes repo is not available in all the Linux hosts. So we'll be adding the Kubernetes repo, and after adding Kubernetes repo, we'll be installing kubectl, kubeadm, and kubelet. And here disable executes. What it means? Disable execute means it will be not be touching any Kubernetes extra repository in case if it is installed. Okay, so systemctl now will be enabling the kubelet service. So because again kubelet is a service which we recently installed kubelet. So kubectl we already defined. Kubectl is used to interact with the cluster. Kubeadm here, this one kubeadm is a utility which will be helping us in installing the Kubernetes. And kubelet is an agent which is inside our node. So this is a kubelet. So kubelet will be starting the kubelet and will be enabling it permanently. Okay. So, and the last one will be starting the Kubernetes cluster. We wanted to initialize the Kubernetes cluster with the help of kubeadm. So this command is kubeadm init. So we are just informing kubeadm just to initialize our installation. Where control plane. So control plane is master. Initialize our control plane, and endpoint is a master of it. So in this node, we wanted to install Kubernetes. In case if we give some another IP or another host name, Kubernetes will be installed on that, and that server will become master. Okay, so this one. So again, this one I copied from the Kubernetes one. From once Kubernetes installed, then we can copy paste it here. So why it is used? It is required when here it's a this Kubernetes join command. So whenever a worker nodes, whenever we install Kubernetes master, it is giving this kind of output. So this kind of output is used when we in a future. So, and this kind of output is used. So this is a token which is generated by Kubernetes master server, so that we can add worker node. So simply we need to go inside the worker node and run this command. So this is just an like a command which I copied from my last installation. So another some more different configuration will come. Another token will come, which will be just copying and pasting here. So and just always copy and paste, because again most of the time like our labs won't perform in very good fashion all the time. So sometime we require to join the Kubernetes node or worker node. Okay, so we'll be covering this a practical session. Then what we'll be checking the kubectl get nodes. In this kubectl get nodes, we'll be checking whether how many nodes comes inside the cluster. So kubectl get node means in a cluster how many nodes are there. Okay, so what happen after installing nodes? Node will not come as a ready state, but it will coming inside the cluster. So here, like by default, we have a settings, IP settings of DNS, of host DNS, or maybe we can say like external DNS. But Kubernetes internal inside the Kubernetes want their own network, which will be assigning IPs to pods. So here, there are too many options available. What we call as, let me flannel, VNet, and Calico. Okay, so but this time we'll be using a Calico network. So we'll be installing a Calico network. So on kubectl apply, and this is the like a GitHub from where we'll be downloading the Calico settings and we'll be installing it. Now we'll be checking Calico ports, whether Calico is installed properly or not. So here we'll be checking in Kubernetes. So kube system is a by default namespace. We'll be covering in next slides. What is the namespace? So namespace will be covering, and whenever Calico or some admin kind of installation installed, so it will be going in a Kubernetes kube system. Okay, so we'll be watching the ports whether so it will be checking some commands. Okay, so kubectl get port. So this is what we discussed, and N is a hyphen N is a kube system. So kube system is a Kubernetes namespace, which is where all admins kind of services are running, as services or the pods you can say. Okay, so now here, what once we get the token from master, then we'll be running this kind of token inside the worker nodes. And once we run this kind of token in worker one and worker two, worker 1 and worker 2 will come inside the picture and they join the cluster. Okay, then we'll be checking again the Kubernetes node, whether all comes under, then we'll be creating some deployment or loading some application. Okay, then I'll be show you like how to take a snapshot of all the nodes. Okay, so this is all about theory part. Now let's go toward the VMware workstation, and in this VMware workstation we'll see the practical way. Okay, so oh, okay, so this is the lab what I was telling about. So this is VMware Workstation. In this VMware Workstation, I installed three machines. So master one, master 01, worker 01, and a worker 02. So what it does, it's a keeping made a layer of virtualization on top of our laptop or maybe server, and of course installing we can create some virtual machine. So they are the segregated virtual machine. Their CPU or RAM is segregated, or we can say separate, and we can get the IP settings from here. So this is the console, but the server one, master one, worker one, and worker two. So we will be taking some remote on with the help of MobiXterm. So MobiXterm is again a software which we I discussed earlier. So this is like we can work efficiently. So there are too many tabs we can open. There are multiple tools, but whatever is feasible for you, you can utilize. Apart from that, you can use Putty as well for worker 01 and worker 02. But I like this one, so I'm using this MobiXterm. Okay, let's start. So let's check its IP. Okay, so whenever we run this command in config, so we will be having some adapter. So 192.168.1.7, this is the IP of master node. In the same way, I'll be okay. Okay, so we can see the IP 7.8.8. So this is again a fluctuating, and let me stop or pause and okay, some issues with that I already fixed. So right now what we can see, master IP is 1.7 and the worker node is 1.6 and worker 2 is 1.8. So the all the IP I have given in MobiXterm in the settings. Now all the servers are up and running fine, all three servers. Now let's go here in VMware. I wanted to show you something. Okay, so right now we'll be taking some snapshots. Okay, so snapshot what it means like original null 9 RHL 9 installation. So whatever whenever we do installation, we will be taking a snapshot. Once a snapshot will be taking. Suppose we install one software, XYZ any software, and we want like this state should be preserved, and we wanted to install some more services or tools later on. But we want in case if something is required, we wanted to come back to that state. So in the last, we'll be taking some more screenshots, maybe some more snapshots, which is called as K8's installation. So once we install K8, K8 will come here, and this URL here will come in the right side. Okay. So in this way, in case some our lab is not working perfectly, then we can go back to the stage and we can fix the lab. So the lab will go to the old stage. Like in the Windows, we guys have seen a restore point. So we are restoring our OS in some different points. Okay, let's move toward. Okay, so with this is our prerequisite we already discussed. So what are the prerequisite and settings? So 2 GB of RAM is required, 2 CPUs are required, and 20 GB free disk is required. So we'll be deploying this cluster on RHL9 with the help of QADM. Okay, now we'll be defining that's already discussed like RHL in RHL9 one will be master, one two will be worker 01 and worker 2. Okay, so first of all, we have to change the name. So whatever the name, so our name should be something like it should reflect that we are working on master or we are working on some other instance. Okay, so let's change. So it's already I already changed, but I'll be showing you that how to change. Okay, so I just clicked on master tab and okay, so right now let's change the settings about the change the host name. So whatever host name is there, so we have to just change it to master. Okay, so master host name it's showing. So let's see. Okay, so what the host name is showing? Master one the DevOps Lab IT.com. Okay, in the same fashion. So in case if it's not coming, then you run a bash and it will pop up. Okay, let me show you in case some different name is coming. Okay, so sleep. So what's coming? Slave 01. But again, we have changed it to okay. Let's change it to master 01. Suppose slave 01 is the host name. Now let's see master 01. Okay, and in case something is coming, then run the bash command. It will reflect properly. Now let's run toward master worker 01. This is when we are on master, so we have to go in a tab and let's run worker 01, and the same thing will be running in worker 02. So I've executed this command many times in this box. So this will work in very first time. Okay, so this kind of entry we wanted to add in all three servers. So first of all, let's add this IP here, and in the one shot we'll be adding an etc host file. Why we want? Because again our server need internal communication. So for internal communication, we are using suppose master 01 and master 1 with this IP. So for IP, because right now we don't have any DNS and nor we want it right now. Some DNS server or DHCP server we not wanted anything. So we'll be using some local settings only. Okay, so worker 2 IP is this one. So let's update here 192. Okay, so worker 1 IP is 6. Now let's check master IP. What is the IP? It's 7. Okay, so master 1 IP is 7, worker 1 6 and 8. Okay, so no worries. So let's move forward and update the settings. So this is settings. Earlier settings we have to delete it. Okay, so now let's add it. If you follow the SOP, then you don't won't face any issue. Let's add an entry. Now we'll be checking whether server is communicating with each other or not. Okay, so we are on master. Let's see whether we are able to make communicate with the master. Yes, it's able to communicate to one also. and it's communicating to 3 also, sorry, 2 also. Now, this is like our master instance will be able to communicate to other two worker nodes. And in the same fashion, we'll be checking worker 01 will be able to communicate to other host or not. Okay, so master it will be able to communicate, worker it is able to communicate and as to the same host. Now worker 02. Okay, no worries. So it's good. Now let's check whether its worker 2 will be able to communicate to master 01. Yes. Worker 01. Yes. Zone host is able to communicate himself or not. Yes. So this is all done. Now disable the swap file in all host machine. Okay. So I'm disabling the swap file in all the machine. So once we open multiple tab, then it's very easy for us to run the same command. Either swap enable or disable. We are just focusing to disable it. But in case if it's a production box, then you have to see it. Now what we'll be doing, we'll be disabling the SE Linux. So we are disabling SE Linux in all the three terminals. Okay, now we'll making it entry in permissive entry in config file of SE Linux. So this is a entry we made in entry we made. Okay. Now we wanted to add some kernel modules. So in master host only. So we need to add this one in master host only. So now we have added. Now again, what are the changes we did right now? And these changes are temporary only. To make it permanent, we need to create one file and add an entry. Okay. So this is again this kernel module entries are done permanently. Now what we want some IP kernel forward parameters are there which we need to add. So because again we are using bridge setting. So bridge setting are basically used in virtualization to so that server will communicate efficiently. So we are also making some settings. You can consider this is like some settings which we wanted. Okay, so this is all I added here, and now we wanted to load all the parameters. So this we added, and these are the firewall rules which are required, which we require when we wanted to run the machine and it having some firewall installed. So let's run one by one all the command. Okay, so firewall D is not running. Either stop the firewall or in case the firewall is running, let me check here also. Okay, let me enable it. Okay, so we have seen this firewall is already running now. So I'm showing this one because in case someone receive the firewalls, so it's already enabled. So in case if it's already enabled, it will give the entry of this one like already enabled. In case if it's not enabled, it will make an entry that says enable. But here the success message arrived. Okay, now we'll be adding some more ports and a reload. Reload also success. Now we need to add some settings in worker node. So this entry we need to add in worker node. So here also firewall is running. See here success, success. Okay. Now we'll be adding some more settings in worker only. It is not for master node. Okay. Then the reload command. Reload command we fired so that all the rules will be appear properly or they will come in sync. Okay, so now what we want, now we want containerizations. For containerization, we are using containerd. So since we don't have repo, now we'll be installing repo in all the hosts. So this is again will be adding a repository. So it means we are downloading the repository. So downloading the repository will take some time because let's wait for the some time whether okay. So here it is updating the repo. So let's see. Okay. So what it says like a Docker repository is available now. So this is the repository which we wanted. Okay. Now repository is available. Now we can and we have installed the Docker repository in all the hosts. So in all the three hosts, we have installed the Docker repository. Now we have to install container D in all the host. So let's install one by one. It will install all the container D in all the host. Let's see. It is installing. Let's go to the last one. Okay. So once container D installed, we'll be restarting the services and we'll be moving towards system C group. It will be taking some time. So let me pause. Okay, so here it installed container d.io from Docker CE stable. So this is a repository in size 44 MB. Okay, so we have installed the Docker container and this one we have installed in. Okay, so this is still running. Here it is installed. We need to wait for worker 01 and worker 2 is installed. Okay, it is installed for worker 01 as well now. Now we have to start container D service in all the host. So let's enable one by one. We have enabled in worker 01 and we'll be enabling in worker 2 as well. So in one shot we have started and enabled. So enable is used for permanent one. Okay. Now we'll be using some container settings. Systems C group. In all hosts we wanted to fire. So let's run in all the host. Okay. Now this setting in master worker and 2. Now let's restart the container D in all the host because recently we installed the container engine. So let's restart. So restarted and restarted. So we have installed. Now sir, turn for Kubernetes installation. So Kubernetes again repo we don't have right now. So for me repo is there. So but I want like you guys to create one repository. So once you create one repository will be installed and this repository we need in all the hosts. So you can see here. So repository is created in all the hosts now. Okay. Now what we want it to install. What all we install? Kubelet, kubectl and kubectl in all the hosts. So let's install it. So this Kubernetes, what are the tools we are installing? Kubectl, kubectl and kubelet. So it will be installed shortly. It won't take too much time. Let's check. Okay, so here it is installed. Worker 01 also done. Worker 02, it's running. And it's also done. So again, here we have done. So now let's move toward the next step, like kubelet service to start in all the nodes. So it started. Here also it started, and here also it started. Okay, now what we want like a control plane to be installed in master node. Okay, so let's go toward a master node and erase it everything. Now here this command says kubectl please initialize control plane in this master node. Okay, and we are already in master node. Okay, so it is saying like old word. Okay, so now we'll be installing the Kubernetes. So this will be allowing. So in case if some people are guessing getting some issues, so just firewall stop the firewall so that it will be allowing. So here now your Kubernetes control plane has initialized successfully. So here we can see like Kubernetes control plane is initialized and it is coming with some commands. So what this command says, this is very important command because it is making a Kubernetes configuration. So what will happen? It will be creating a kube folder. That .cube means as a hidden folder. So hidden folder, what we want, like admin configuration. So this is the file, admin configuration file of Kubernetes, which make any one person as an admin or any user as an admin. So in case if this file is copied to another folder, or maybe then that person will become admin. So what we'll be doing, we will be copying that admin.configuration file in our whole folder, home folder. Also, it will be changing its owner permission. And here we can see, in case if we have some more master, so we can add this command. Go to that master, the like master 02 or 03, then we can add this command. So this is again, it's called as a token. And this is a like a worker token. So you can join any number of worker nodes by running the following on each node. So this is worker node. Okay, so let's copy this one to our notepad. So whatever is written in my notepad, I'll be replacing it. So this is required because again the token are utilized on a later stage also. It's not for right now. Okay, so we have done now. Now let's check Kubernetes get nodes. So kubectl get nodes, but we won't be getting any nodes. Reason being because we have not done the configuration, so which was we seen earlier. So this one is a kube configuration file. So let's run all these commands, then only we'll be able to get the nodes. Kubeadm dot folder, and then we'll be adding a admin dot configuration in our home folder, then changing the permission. Okay, post changing the permission, then we'll be checking kubectl get nodes. Now we can see now only one node is coming and which is ready, and master 01, this is the part of our cluster right now. So right now worker 01 and 02 is not in the picture because we not ran the token command. So let's run this token in a worker node. Okay, so that they will also join. Let it run in worker 01. In case if everything is success, we will run the same in worker 02 also. So it is right now, it is checking some pre-flight checks. Now see, kubectl get nodes is done. Let's run the same command here. Okay, so it says like kubectl get nodes on the control plane to see the node joined to the cluster or node. Let's see here. See, now it is joined the cluster. So we can see like it's not ready. Others are, but it is joined the clusters. So just hold. This is not showing ready. So let's go to a worker node and make a Kubernetes Calico configuration. So let's apply the same. Okay. So it's saying connection refused. We need to okay, by mistake I run this command in worker node, so this command need to be run in a master node only. So let's see. Okay, so uh, this our Calico network is installed here. So now let's see Calico network is installed or not properly. So kubectl will get nodes again. Let's see. So this one is ready, but others are not showing ready. Just hold for a minute. Okay, so you can see here some pods are still running Calico nodes. So it is in the initializing state. Let's wait for some time because Calico nodes are just now initialized. We can wait. See again, this one is initializing. Now everything is running now. Let's see. All the nodes are in ready stage. So what happened? Like it will calculate the network which is used to make the network setting between the Kubernetes cluster. Okay, let's move toward the next stage. What it says. So this part we already covered, and kubectl get nodes. We already added a Calico network on the master node, only on master node, and Calico pods. We have seen the Calico pods were there. This one we have done, and let's see kubectl get join wide. Okay, so this is a wider approach. Like there's a master instance, all are ready. In case if these are not coming in a ready state, so means either you have to watch the containers, or I mean to say like a pods, whether pods are up and running or it will be in an initializing stage. So at least wait for 5 7. In case if it's not running, wait for 5 7 minutes. It may be in initialization state, and so again it's a IP 768, whatever the IP of the nodes, and its images RHL9. Kernel version is this one, and container in runtime is this one. So now our cluster is ready. So let's see. Nodes. Okay. So pods. No pod in the default namespace. Cube system. Let's see what is available in cube system. Okay. So all the pods are running here. So in case if some pods are not running, then it will be creating a problem. So it's not running. And sometimes it's case a firewall is creating problem. So we can stop the firewall. Okay, so this time our pods are working perfectly and our Kubernetes working. Let's run our deployment. Let's create a deployment. In case our deployments we are able to create, that means our cluster is working perfectly. Okay, now let's expose this the same deployment and kubectl get service. So everything is working perfectly in this cluster. Now let's suppose a case. Tomorrow we are just coming again after shutting down the lab and we want it. So there's a command by which we can see the token. So token are two kinds. One is like it was created by the time of cluster initialization, and second will be like we can regenerate the token. So let's fire the command token list. Qvdm token list. Okay, so this was a QVDM by mistake. Okay, fine. So this is like this is a token. This is a token, and in case if this is a default bootstrap token generated by QVDM in it. So at the time of bootstrap, this token was generated, and we have kept written in our notepad. But this time it's a new token also. Let's generate a new token. Okay, suppose a case when we wanted to generate a new token. What will happen? Like, see, this is the command to generate a new tokens. Earlier, two tokens were there. Let's generate a new token. This is a new token generated. So simply what we have to do, we have to use this command and go to our worker node and paste it. Suppose after 2 3 days we wanted to add the worker 3. So right now at that duration we don't have a token. So where to generate the token? From here, from this command we can generate the token. Okay, this is all about installation of Kubernetes in VMware. Hope you enjoy the session. Thank you and have a wonderful day.